So next is the interrupt driven data transfer scheme. So basically one of the drawbacks of the aforementioned program data transfer scheme was that the wait time required by the programmed data transfer scheme was very large. So basically a lot of time was wasted by the microprocessor in order to wait for the IO device to get ready, especially during the asynchronous method of data transfer. So basically here, in order to overcome that difficulty, we are receiving the data via interrupts. So hence this method of data transfer is termed as an interrupt driven data transfer scheme. Here the IO device inform the microprocessor that whenever the data is ready to be transferred to the microprocessor via an interrupt. So that is the IO device inform the microprocessor for the data transfer whenever the IO device is ready. So when the microprocessor gets that signal from the peripheral device, the microprocessor will send the interrupt signal, and basically the program counter's content will be changed, and the ISS or the interrupt service subroutine will be activated. And as the interrupt service subroutine is activated, the content of the program counter is changed, is removed to the stack, and basically the ISS will be executed in the program counter. And as because the ISS is being executed in the program counter, the control of the program is transferred into the ISS, and basically the data required for the program is in the ISS. So so the corresponding program will be executed via the ISS, and after this execution is completed, the control of the program is again fed back into the main program, because after the execution of program, the data in the stack is brought back into the program counter, and the previous program will continue to be executed in the microprocessor. That means after executing the program for the data transfer, it stores the process data and then it returns to the main program, and basically the main program will be executed by the microprocessor. Here the figure is showing the execution. So basically the microprocessor will be sending an interrupt acknowledgement signal to the IO device, and after the IO device has completed the process of converting the analog to digital quantity or its specified task, the IO device will be sending an interrupt request to the microprocessor, and the microprocessor, after receiving this interrupt request, it will send one interrupt to the IO device. And as the interrupt is being sent, the content of the program counter will be converted into the ISS, and as the control is now in the ISS, the microprocessor receives the data from the IO device, and after that the program corresponding that ISS is executed, and once this operation is complete, the content of the program counter is reverted to the old program, and the microprocessor will continue to execute the older program that it was currently executing while it received the interrupt.